What? Happy Tuesday, everybody. Captain Coder here on this beautiful Tuesday morning for me. Good morning, good afternoon, good evening. Whoa, thank you for the woes. Good morning, good afternoon, good evening to you wherever you happen to be in the world. I hope you're having a beautiful day. A beautiful day, Corpless. Thank you so much for the I'm so happy to have all you beautiful people with me on this beautiful day. The whole crew's here, folks. The whole crew's here for data structures and algorithms Tuesday. I'm so glad you can make it. MMO Pug, thank you for the hype wave, my friend. It's so nice to have you here. And Corpless, I'm so glad you're here, my friend. And don't worry about being second. Look, Corpless, you, my friend, are first in my heart. First in my heart. We love you over here, my friend. I'm so glad you are with us. We also got Gemini. How have you been today, yesterday, and for the last week? Gemini, I'm so glad you're here, my friend. And Coding Chemist, hello. Almost first, that's right. We gotta get the almost first command. And Practical NPC, I can't believe you're here, my friend. Folks, you guys don't know the Practical NPC, not the Practical, just Practical NPC. Incredible. Okay, I need to get I don't have a Practical NPC command, which blows my mind, folks, real quick. We got to give Practical NPC some love. Practical NPC, can you share a link to your project? Do I have a practical? Hang on, I might. I do have a Practical NPC command. How could I forget that? Guys, gotta go check out Memory. Look, I do have it. You gotta go check it out, folks. Go give this game some love. Look at this beautiful 2D pixel art game by the incredible Practical NPC. Wonderful. Han says, by the way, will you cover immutable data structures? We can cover some immutable data structures. In general, I think immutable data is the best type of data. But guys, hop on, go play the demo. Memory, play the demo, add it to your wish list. It's gonna be awesome. Ben, the developer. Ben, you can post it on the Discord, my friend, if you want to. You can post it in Showcase Saturday, or if you don't want to show it up on stream, you're welcome to post it in the share section. But the best way to share your work on stream is going to be Showcase Saturday, folks. Showcase Saturday, which I'm so excited. I'm so excited. We had such a beautiful showcase Saturday last time. It's wonderful. It's so nice to have you all here with me. We got the coding chemists. We got Practical MPC folks, incredible stuff going on here. Lo-Fi Craft, how have you been, my friend? It's so nice. It's so nice. It's so nice to have you here. Lo-Fi Craft, Showcase Saturday. Posted on the Discord thread for Showcase Saturday. We'll hop on. We'll take a look at it on stream. I'll have to install the Roblox. It'll be great. Frostern 1216. Welcome back, my friend. How are you? I'm so glad you're here with us on this beautiful day. I'm so glad you could be with us. Frostern's asking, I know it's not ready, but can you explain what you meant by the goal of a hash table to provide efficient insertion and retrieval of data? What kind of data, and is it random? Yeah, so the idea with a hash table is you want to have random access lookup, or as fast as possible. You want to be able to look up data as quickly as possible to be able to share that information. So an array gives you random access. You say, I want index 5, boom, you get index 5. You want index 12, boom, you get index 12. What you might not realize is your data might not be an integer. You might want to look up something like the word hash. Maybe you have a thing that you're looking up a definition of a word. People are passing words in. You want a quick way, you want an efficient way to do it. Well, you know what you might do? You might put in a hash. Wouldn't it be cool if I could index by the word hash? I could index by the word hash and get back the definition. So we're going to be looking at that hash table. They're called dictionaries. Typically, they're called dictionaries. In CSharp, Python call them dictionaries. JavaScript, I think they're called dictionaries. They might just be called arrays in JavaScript if I don't quite remember for sure. In Java, they're called hash maps. Beautiful data structure, one of the best data structures. Snabble, fuel, Snabble, fuel, Snabble. Welcome to the stream. Ben the Driller says you don't have permission. Let's take a look at that. Are you on the Discord? What can you... Oh, I was going to say, can you send a screenshot of your message on the Discord? But since you don't have permission to do that, then I'm so glad you're with us as well. Good afternoon to you, my friend. Good morning from me to you. It's nice to have you here with us on this beautiful day. Froster, and I hope that made some semblance of sense. We're going to talk about it a little bit more. To get in there. And Thindle says, I've got something to show you, and it's awesome. I made it for Fritz yesterday. Do you got a link for me, Thindle? We might check it out. Or do you want to save it for Showcase Saturday? It's going to be up to you, Thindle. What do you want to do? If you want me to take a quick look, I can. They're called hash tables. They're just implemented as dictionaries. Smab, am I wrong? Is dictionary and hash table a different thing? I know that. So there's a data structure in C# called hash table, but it's the generic type. So often you might call them dictionary. Is a dictionary a hash table? I could be wrong. Is a dictionary a hash table? A dictionary is a data structure that maps keys to values. A hash table is a data structure that maps keys to values by taking the hash. Okay, all right, so I'm wrong. Okay. So a dictionary is sort of like a more generic. You don't know about the implementation because sometimes you might have a tree map. Yeah. Smab. Thank you for Smab. I love you, my friend. You're always calling me out, keeping me honest, making me think twice. And making me a better programmer. 50 points to you, my friend. Thank you so much for that. But yeah, so the idea is you have a mapping. And I kind of, the word dictionary just means like a quick lookup. You want to be able to look things up relatively quickly. Yeah, there are many kinds of dictionaries. That makes sense, Snabble. In Java, they call them hash maps. What else? Hash maps. What is it? Hash maps. What is the other one? Tree map. Hash map, tree map. And then you have IMAP. Not to be confused with the with Apple. It's not an Apple thing. It's just the map interface, or is it just map? I think it's just map in Java because I don't put the I's in front of things. Anyway, I'm rambling. So happy to have you on here, Smab. I hope you've been well. Thank you so much for being here with us. Thank you for having such insightful things to say. I love having you here. Giorgio, welcome to the stream, my friend. I'm happy you're with us. I'm happy you're here on this beautiful day. iCaptain, new streamer from Apple. That's right, Muniz, the new and improved. Objects in JavaScript, or maybe I just call them that. Yeah, everything in JavaScript is kind of just, well, everything in Java is a JSON object. JavaScript object notation, everything's just an object. In fact, everything in JavaScript, it's kind of just a lookup table. I think everything in JavaScript is actually just a hash table, which is kind of interesting and fascinating. Keep things simple. Of course, I could be wrong. Everything in JavaScript can be like indexed into. It's kind of cool to think about. Hanso High was asking, will you cover immutable data structures? My plan is to cover. Look, I'm a big fan of immutable data. When your data can be mutated, when you can mutate things, that's when bugs happen. So if you remove mutability, if you take mutability away, you eliminate that. Hanso, can I post link here? It's like a cheat sheet for Java's collections. Quite good. See if it'll let you post it. I think I have it set up to where people who have been in the stream for a long enough time are allowed to. And it should be historic. It shouldn't be just for today. So try and post it. It might time you out for a second, and then you'll help me test it out, Han. You'll help me test out Dramux. Where are those data sets you keep talking about? The data sets. What do you mean? What data sets? What do I keep talking about? I don't know. I say a lot of things. Hidden in the unit test. That's right, Moon is. So happy to have you with us on this beautiful day. Let me see here. Keep reading here. Could we have some vegan bacon? Snamble's asking Thindle for some vegan bacon. You didn't try my game, still Lo-Fi Craft. Get it on the showcase Saturday, my friend. We'll check it out. It's a Roblox game, right? Lo-Fi Craft, let me know if I'm wrong. Is yours a Roblox game, or is yours the remind me. There's a lot of people here. I'm so sorry if I don't remember. Yours is a Roblox game, though. Is that correct? Or is yours the game where you combine cars together? You like build cars. I can't remember now. Lo-Fi Craft, I'm so sorry. Ben says, check my 2 low poly characters out. Give me a second, my friend. You can't just be demanding stuff like that. You got to be patient. You're not the only one here, Ben. I'm glad you're here, but I'm glad you're here. But we got to be patient as the captain reads through. There's a lot of things going on. They're implemented as dictionary. Smab, thank you for that. Hanso High. Let me take a look at this real quick. Bear with me. Oopsie doops. Close that. Showed my history. I don't think there's anything there. Let me double check here. History. I hit some. Apparently there's a hotkey that will open up history. Okay, nothing crazy got shown, I don't think. I don't think so. I'm looking at my history. I don't look at anything crazy. I just wanted to make sure. You guys saw that. Then Devro, happy to have you here. Ooh, let's take a look at this. Hanso High, thank you for the link, my friend, and thank you for helping me test that out here. All right, start. Will it contain? Ooh, this is an interesting. I wish I could zoom. It's a little bit fuzzy. Will it contain key value pairs or only values? Pairs and values, yeah. So this would be like whether or not you should use some sort of looking up thing. Oh, this is a really cool flowchart. Hanso High, thank you for sharing this. Points. Add Hanso High, 50 points, my friend. Thank you for sharing. Froster asks, if it implements a dictionary, what do people use as dictionary for? I think they're used for select functions or something. I don't know, make their own dictionary, but not sure why. So the idea with the dictionary is just to have a mapping from keys to values. The idea is just keys to values. Doesn't actually have to be a specific thing. So it's generalized. The idea with the dictionary is it's kind of generalized. Keys to values, that sort of mapping. Really cool flowchart. I wish the quality was a little bit less fuzzy. Hanso, I thank you. Profits, this looks there. Where in there do I get a coffee and a break? Looks around. Look, anytime you need a break, you just got to get up, walk around, take a nice sip of that coffee, maybe get some of that fresh water. Oh, you gotta take care of yourself. Take care of your health. Love yourself. Love that body. Love you the way you deserve to be loved because you're a lovely person. Prophets, we love you, my friend. We also got the overgrown carrot. I'm doing fabulous today. How the heck are you doing, overgrown carrot? I hope you're doing fabulous. Folks, before I forget, we gotta give Dev Rowe a shout out. Hang on, Dev Rowe. Is it Dev Rowe? There we go. We got it. Incredible, talented game developer, 3D artist. You gotta check out his stream. Lovely human being. Mooniz, thank you so much for that. Thank you so much for that there. I appreciate you, my friend. Mooniz, you are correct. You are correct. Folks, we have it set up. If you really want me to see something, you can use the question command. It'll add a note to my queue. So check this out. Check this out. I have this queue over. If you really, really want me to see something, this question. Question, Captain, why are you so short? Boom, adds it to my question queue, And then when we go on, when we have a little moment in time, when we take a little breaky poo, after we do our stretch break, I'll try and answer your questions. We try and do that midstream, folks, because there's just a lot going on. There's a lot going on. The captain loves you. We got a lot to get through. All right, folks, thank you guys so much for being here. We love you very much. I appreciate you. Look, folks, a hash table. A hash table here is, look, it's easy. You just take some hash browns, light this tennis racket on fire, boom, whack that object. It's going to hash it on down. It's going to hash it on, and then you're going to have it. Yeah. So there we go. So folks, we're going to be looking at hash. What the heck is a hash table? You probably, if you're programming, you're probably using them all the time. You don't even realize you're using it. One of the things I always say is, if you got some problem you're trying to solve and it's not quite working, a hash table, a hash map, a dictionary probably solve your problem. And if that doesn't work, try two dictionaries. It's beside my eggs and bacon more. That's right, prophets. That's right. It's your hash table. It's a table made out of potatoes, but they're glued together with cheddar cheese. Oh, it's a hash table. My favorite breakfast. All right, so let's take a look. I've set up a very big corned beef hash. That's right, a corned beef hash. We're gonna run a corned beef hash function today, folks. Yeah. So anyone who doesn't know, not anyone who doesn't know. I have set up here, I took a little bit of time, set up a little CSharp solution here. So we have our hash table solution, so we can start coding some stuff in here. What the heck is a hash table? I should have gotten my Remarkable pulled up here real quick. Let's do that. What is a hash table? Why do we like hash tables? What are hash tables? Who knows? Oh, don't know. I don't want your update. Remind me later. Everything wants to download. I clicked down. I said update later, and it's like, okay, I'm going to go ahead and update now. All right, fine. We'll do it live, folks. We're doing it live. We're installing. It's crazy. I wish you guys, I don't know if you saw it. I think it was on the other screen. I literally clicked remind me later. And I was like, all right, we're going to update. Boom. All right, whatever. Whatevs. What to the evs. Here we go. All right, connect my Remarkable here. Folks, I'm so glad you're here with us on this beautiful day. We're going to present with screen share here. Accept. All right, folks, we're live. We're in. Few milliseconds later is not what you were after. Yeah, correct. Look. I don't have that. I don't got time for that. I guess that is technically, yeah, I know. I was like, no, remind me later. It's like, gotcha. Okay, we'll remind you now. Making you hungry, coding chemist. I'm kind of hungry too. I meant to eat a little bit before the stream start, but that's okay. All right, so hash table. That's what we're talking about. What is it? What does it do? Why do we use it? Tommy Luco, welcome back, my friend. Tommy, how are you? Tommy, welcome back to the stream, my friend. I'm so glad you can make it today on this beautiful day. All right, so we got a hash table. The idea of a hash table. So here, let's talk about a program we might want to write. Here's an example. Write a text analyzer. Text analyzer. Is that how we spell analyze? I'm not sure. Text analyzer that builds a histogram of the words that appear. For example, the prompt has, let's look here, right appears one, right appears once, the letter A appears twice, A appears 2 times, text appears once, analyzer appears once, analyzer appears once, that appears once, that appears twice, once, twice, that appears twice, builds appears once. Do you see what I'm going at? I dropped my mouse. Sorry about that, folks. I destroyed everything. My mouse went flying across the room. All right, so we're gonna build a histogram where it counts. Given some arbitrary text, I want it to count the number of words, the number of occurrences of each unique word. Does that make sense? Ryan, welcome back to the stream, my friend. So nice to have you here on our Data Structure Tuesday. We're talking about hash table. So how would we do this? What might you do to do this? Well, let's take a look at this problem. Let's take a look at this problem and how we might do it without a hash table, how we might think about doing it. Okay. Let me create a program here. Come up with directory. Make .NET new console project. Console. We're gonna make a project called text. What would be the thing that says like counts the word counter? Text analyzer. Like this. So we're gonna make a text analyzer. CD text analyzer. All right. Let's open up this program here. All right, so text analyzer. We want to write the following function. It's going to give us back. It needs to give us back something like the following. So we want to. The function's hard to write without saying a dictionary. But Ryan, I'm having a beautiful morning, my friend. I hope you're having a beautiful day. Welcome back to the crew. All right. Given some text, given just some arbitrary text, max funky. We've got funky to the max. Welcome back. All right, so I want to do the following, so int. Let's do the following. It is a little bit interesting. Int count words. All right. Ooh, I got an idea. We're gonna return a pair of string 2 ints. Okay. Words count, and this is gonna be an array of these. So we're gonna count words, string text. All right, so the idea with this, and I gotta add this to my solution, 1 sec. .NET SLN and a text analyzer here. Max, are we making stuff with Unity later? Unity is in the tag. Sorry. We'll be Game Dev Tuesday. Let me update my tags there. The tags, we do Unity stuff sometimes. We're not doing Unity stuff today. Thank you for letting me know. Let me update that tag. We are doing data structures today. We're talking about hash tables. We're talking about hash tables today. Today is Tuesday. Yes, it is Tuesday. It's Data Structure and Algorithms Day. So count words. All right, so the idea is that we're gonna get back sort of an array here. All right. Creates a histogram of the words in the provided text. All right, creates a histogram of the words in the provided text. We're creating a mapping from each word to the count in them. And we might do this with a dictionary. All right, we'll do it with a dictionary. Dictionary, string to int count. All right. So word, can I name these? Can't do that. All right, so we're gonna go from strings to integers. And so we're gonna build this up, and then we're gonna talk about what the heck is a dictionary doing inside that makes it so efficient, makes us be able to do this. Yeah. So we do game dev on Thursdays. Sorry about the confusion there. Adam, welcome back to the stream, my friend. How you doing? How have you been? What have you been working on? Adam, I know you're always making something cool. You should check out. I hope you'll submit something to our showcase, because I'd love to see what you're doing. All right. So one way we might do this is we might go through and we might find all the words, and we sort of have to assign each one some kind of number. But essentially we want to go through this text. So we take this text, we're going to split it into tokens, split it on the white space. We're going to have text.split. And to split it on white space, I believe we give it null here. I know it's a weird one. So it's going to give us back just the words, string array words. And I like to call these ones tokens. So it's going to give us back all of the tokens. It's going to give us back all of the tokens, each individual word in here. And then we have to count the occurrences. We have to count the occurrences. And we might do something like this. Here, I'm going to change this. Count words. Count words. All right. Bear with me. I apologize. That's interesting. Keep changing my mind. Count words, string text, and then string word. Okay. Count the text, count the word. Count the text, count the word. All right. So it's going to find this word in this text and then tell us the number of times that word occurs. So you might end up writing this at for each string token in tokens. Count it. So we're going to start, we say, well, I'm going to start out with my count equal to 0. I found it 0 times. And then each time I find the token, if token equals word, count plus, and then we return the count at the end. Does this function make sense? I'm going to get rid of histogram. Given counts the number of times the specified param ref name equals word. The number of times the specified counts the number of times the specified word appears in the specified param ref name equals text. So you might write it this. It might be in front of them. Smab says, I'm intrigued what part of the word they are adjacent to with this approach. Yeah, Smab, you're correct. You're correct. They will be there. So you'd have to do a filter where you take out all of the non-characters. This only deals with white space. That's true. That's true, Smab. So Smab, what could we do? What could we do? We could filter out all of the non-characters, right? We could filter out all of the non-characters at that point as well. Smab, excellent point here. And because I'm working on something cool, I couldn't watch stream because I don't have much internet, but it's end of the month and I have some internet left, so it's time to use it. Gotcha. I'm glad you're here, my friend. I'm glad you're here. Yeah, Practical NPC is here too with Memori, amazing streamer. You are correct. You are correct. So you would want to, so ideally you'd want to do some kind of filter ahead of time where you remove all of the non-space. So we could split this way. There's a variety of things we could do to clean it up a little bit for our purposes. But you're absolutely right. For our purposes, we're going to pretend that our data is clean, just for demonstrative purposes. A demonstrative or demonstrative? Demonstrative. What do people think? How would you pronounce that we're going to demo that? All right. But we might have this text here. So we might have, all right. You know what? Let's write a little thing that says string clean text. String text. All right. So this is actually going to, better. Let's call this tokenize. Tokenize, Smab. I like this. I like tokenize. It's going to give us back a list of tokens. I could do an array of tokens. List is going to be a little bit easy. Corfless, I am kind of vaguely remember if dictionary is basically like Python, the key is string type and values. That's exactly right. That's exactly right. So Python's generic objects, or they're called dictionaries, in Python. But yeah, you can index into Python dictionaries in the same way you can in C# using string int in between the angle brackets like that. All right, so we're gonna write a little tokenize here. It's gonna take in text and it's gonna given a string of text removes all ASCII, non-character, non-alpha numeric characters and splits on white space. All right, so we'll write a little tokenize here. And look, I'm getting to a point where I'm like, okay, I kind of need to be able to test this thing. And so we might have like a utility class. I want to be able to write a test for it. So we're going to create a new file here for our text analyzer, text analyzer.cs, and we're going to turn it into a static class, public static class text analyzer. I'm going to put it in a namespace, captain coder.hashtable, I don't know, a text analyzer like that. And we'll be able to add some unit tests. So you would leave the hyphenated word smab. I don't want to get too complex for demonstration. Look, this is a demo. We're demoing things here. It's great to have those things pulled out here, but I don't want to get bogged down with little details. Like, it's important to understand that those details exist. But we're going to write a tokenize function that's going to be, try to keep it simple. But we could leave hyphenated words. I don't think it'd be that hard to do. But I'm trying not to get too bogged down. Great points here. Points. Add smab 50 points. Excellent ideas. I do like the idea of having a function tokenized that we could potentially swap out. And you could make a class here and then say, like, which tokenizer do I want to use? This one's going to remove all the alphanumeric characters and split on white space. Yeah, so we'll keep that. We'll keep that. I like that. So the question it starts getting complex. I said, well, now I need to keep things that are I need to detect if a hyphen's in between in the middle of a word, right? And so I'm trying to think if it's at the end of the word, do I keep it? Right? So there's all these little details, and we're not going to worry about those for now, but I think it's an incredibly good thing to think about if we're building a production piece of code. This is more of a demo here. Okay, so our tokenize here, the basic idea is we want to split on the white space. So at the end of the day, we want to do a return text dot split on null and get an array. Oh, if it changes to an array, we end up with an array of these things back. So the question is, can I filter down my text here a little bit to remove those? And I think there's a relatively easy way to do this. Text dot select. Ooh, let me think. Cause I want to remove, so here's my idea. Here's my idea is I'm gonna go ahead and filter out all of the text, filter out anything that's not a space or an alphanumeric, and then split on the spaces is my idea. There could be a better way to do it, but we have to go over this text, split it out, and pull it out. And it might actually make sense to make this a stream so we don't have to do it all ahead of time. There's all these little details that we could work out here, but the basic idea would be that we can split up this text in this way. And so I'm going to say here, to do, we could implement this further. All right, so for now, I'm just going to say, okay, this is all it's going to do is give us back, and I'm going to make this an I enumerable of type string, and this gives us the flexibility to change the implementation later, but I am going to say that I'm not going to worry about this for the purposes of today when we're talking about a hash table. The idea here is I want to talk about the topic, in this case a hash table. So we're going to write a program here that's going to count our words here. So we have count words. All right, so I'm going to take this, I'm going to put it into our text analyzer, like so, our text analyzer, and make this a static public, static count words. It takes in a string of text, This is the text we're gonna do, and it's gonna produce the words, right? And we might even have it take in our token, so we don't have to do that again later. But instead of calling split here, the idea would be that we can call our tokenize function, and then that will allow us to swap out the text later. So we're gonna take this text here. It's gonna give us an IEnumerable, like so, and then we loop through it and we count up the words. This doesn't solve the problem that we were trying to do previously. This will only do it for a single word, right? Single word, and you have to know that word ahead of time. So we'd actually also need to know all of the unique words inside of our chunk of text as well. So we could also write a function, public static string array or list, something along those, find unique, or we call it unique words. All right, so string text here. I'm gonna make this one again. We're doing things sort of in what I would call an inefficient way, right? Inefficient way to demonstrate the problem it's gonna solve. So we have unique words. We're gonna loop through some text here. Finds, given, we'll say here, given, finds the unique tokens, unique tokens within the specified, and this comment here I'm struggling with a little bit. Why didn't my param ref name equals text? The autocomplete here is killing me. Find the unique token with this bit of text and returns them. All right, so the idea is we want to find all of the unique strings inside of this. Again, we're going to use tokenize to do it, and we loop through. In this case, rather than counting, what is our aggregate here? So these are called like aggregate functions. Count words, loops through. We're aggregating over this text here. Count happens to be the thing we're aggregating. In this case, we're not aggregating an integer. We're aggregating a list of strings, in this case, tokens. Like result tokens. This would be like final unique tokens. All right, we'll start out by making this a new list like this. Okay, and then we're gonna loop through, and we're gonna say if, check this out, if unique tokens dot contains token. So if we've already seen this one, we don't want to do anything. So we're gonna say if it does not contain this token, we're gonna add it. Unique tokens dot add, and then we're gonna add in the token here. And then at the end of the day, we return our unique tokens list. Okay, so we could do it this way. This is a little bit, it's actually a lot of bit inefficient. Because it actually has to loop through our tokens here. It has to loop through our tokens each time we do it. So it goes through all of the words and it builds up this thing. We get back a list here of our tokens, and then we might be able to count the words here. So let's write a program that will do this using these two things. So if we have a way to get the unique tokens and we have a way to count each word, we can do it. But then we're gonna look at the inefficiency here. Why is this not necessarily the best way to do this? All right, Batsy, welcome to the crew. Thank you for being here. Thank you for the role, Batsy. Oh, Batsy, thank you for following me today. Batsy, I appreciate you. Batsy, welcome to the crew, my friend. Topologist, is that quadratic complexity? Yes. So this is quadratic. In the worst case. So what does that mean? Can we build up an example where it's like really bad, where it's really bad? And I think we can. Where's my remarkable? Or my remarkable here. All right. So let's look at what we have here for calculating our uniques, for calculating our unique words. Why is it quadratic? Why is this quadratic? What does quadratic mean? So let's build up an example here. Hello, my remarkable. Let me change pages. Why won't you let me change pages? There you go. Okay. So in this example, unique words, stop it. Unique words here. We're looking at this. If we provide a string of text that has all unique tokens, all right, A, B, C, D, E, F, G. All right, so this is our tokens. All right, our tokens are these here. And the issue that we run into is that as we add these to the list, each time it's going to take longer. So let's look at this. The first time through the for loop are unique tokens. Unique tokens is empty. So we come in and we say, does unique tokens contain A? It doesn't, so we add it in there. And then we come back up and says, does unique tokens contain B? Well, to determine that, I actually have to check. I have to iterate down and check. And so I have to actually observe A. So we'll say that A was observed one time. We've looked at it once, and now we add in B. We got to the end, we add in B. And put little tally marks here. So A was looked at once. We come back up here, we're on C. Now I have to look at A again, and then I check out B once to determine that I need to add C to the end of this list, okay? Then I need to come through, I need to look at A again, B, C. The little tally marks here, number of times accessed. We've had to look at these that many times. So this one had to get looked at 3 times. Now we're going to D. I have to look at this one again. I have to look at this one before I can add D. So I actually have to look, as my list gets longer, the speed gets slower. Holy cannoli, it's the dev dad, folks. It's the dev dad. And then we come in here again. We have to add an E. So now I have to look at A again. Now I've looked at A 5 times, looked at B 4 times, looked at C 3 times, looked at D. Apparently I've added in too many things here. E. And then to add the next one, F, and I have to look at this again, this, add in. And you'll see as I add more data to this list, I get slower and slower. So we are looking at how many times do I have to look at this, and the size, it's based off the size here. If this list is size n, I actually end up doing this operation n times. And so this is how we count that this function, sorry, is it n? Or is it n squared? N squared. Yeah, so check it out. It's n squared because I look at this one n times, this one n minus 1, so it's n minus 1, this one n minus 2 times, n minus 3 times, plus n minus 4 times, all the way down. So I actually have to add up n plus, notice, n plus n plus n plus n plus n. If we look, there's a mathematical where we can pull all those n's out, and so we actually end up with n squared like that. Because we're doing it, how many times does this happen? This happens n times. Yes, that's exactly right, Gabriel, that's exactly right. That's exactly right. So that's exactly right, Gabriel. That's exactly right. We are using a bad data structure here. We're using a bad data structure. List is not the right data structure to use. If we use a hash, we can actually save it. And that's what we're talking about, Gabriel. We're talking about hash tables. We're talking about hashing, but we are exploring why. Yeah. Yeah, so topologist, exactly. So as we go down, yes, we don't have to look at them all that much, but we end up taking the concept. We have to do this n times, so we can actually pull the n out here, and this is big O of n squared. Correct, Fuel Snapple, that's correct. With hash tables, with hash sets, we have to have a good hashing function. So the idea, all right, so let's look at this. If I swap this out to a hash set here, what happens, the idea with a hash set, all right, with a hash set, the idea is that we have fast lookup time, O of 1 lookup time. All right, O of 1 lookup time with a hash set. So typically, if we could end up with a bad hash, so Snab was pointing out, if we have a bad hash, it's bad, it's slow. But if we look up time, we're able to get that out, and then suddenly we actually don't have to look at every element in our list, in our sets. We just say, hey, is it there? And it says, yes, it is, or no, it's not, and we get it back. So we can actually do unique words very, very quickly. Very, very quickly. So this contains now takes O of 1 time, constant time. In most situations. So if we have a nefarious person, they might be able to say, okay, well, I'm gonna do the worst. I'm gonna give you a bad hash, something that hashes terribly, and you're gonna be destroyed. You're gonna get crushed, and that happens. That can happen. Dev Dad, I'm so glad you're here. How have you been, my friend? Sorry, I was so distracted there for a moment. And Javasaurus X, welcome back to the stream. Happy to have you with us. The best hash function is just return a random. Oh no. But yeah, so the question is like, how does this work? What is this doing here? So with a hash set, all right. So now we have this other thing, count words, right? So let's write our little histogram program. Let's get ChatGPT to generate some text for us. One sec. Give me a second here. I'm gonna get ChatGPT to generate us some text. Generate what text? Generate a story about. Someone give me a prompt to give ChatGPT. We're gonna generate a story with ChatGPT. Dev says we're doing well, feeling well rested. Computer exploded on my time off, so I'm setting up. Gotcha. All right, generate a story about bread. All right, we're gonna generate a story about bread. The magical loaf. Here's the story we got, and we're gonna do the analysis on this. And the issues Smab was talking about are gonna show up in this because I'm already seeing punctuation, and so we'll have to clean that up a little bit. All right, so here's the story about bread that we got. Thank you for your suggestion, Ben. Thank you for your suggestion. So here's the story about bread. I'm gonna save this in a text file actually, because this is a little long to have in a string, just a generic string here. All right, 1 second. We're gonna come over here. We're gonna call bread.txt. All right, are you guys ready for story time? Once upon a time, in a quaint village of Millbrook, nestled between rolling hills and whispering brooks, there lived a young baker named Elise. Her bakery, Golden Grains, was famous throughout the land for its delicious bread that seemed to possess a magical quality. Every morning, villagers would line up outside her bakery, waiting eagerly for the freshly baked loaves. So what we're gonna do is we want to say, okay, well, how many times does Elise show up? How many times does Secret show up? How many times? We're gonna build a histogram and build out sort of the number of times each one of these words shows up in here. Each time one of these shows up in here. So we're gonna write a little program here. I need to get all this text in. So let's write a program. Let's write a little program to get all the text in. So string text, and I think it might have to import system.io. Let's do file. .read all text, really simple, bread.txt. It'll load it in here, and then I can do console just to test it out, right line text. Let's take a look here. .NET, I'm pretty sure this will work. This is in our text analyzer, .NET run here. Let's take a little look here, and this should hopefully just print our text out. All right, so we get our text. I have my text loaded. That's our first step. The next thing we got to do is we got to pull some out. And Ben, the developer, thank you so much for your suggestion. 50 points to you, my friends, for your beautiful bread story. All right. So the idea is we have our text analyzer, and we can do get unique words, right? Get unique words on this text. This can give us back a hash set of string text like that. Tokens. So now we can know how many different words are actually in this. How many different words are actually in this? So we're gonna do a for each string token in tokens, and then we can look at them. Console.writeLine token. All right, console.writeLine token, and we'll see all the different words, and they're unique. So these are all different words, and we run into the issue Smab was saying, like, well, now love, comma, shouldn't be love, comma, the semicolon. So we're gonna fix that. We're gonna fix that. We got to be able to keep apostrophe. So there's some like weird things in there. I'm gonna remove all special characters. Maybe we need to keep hyphens in between. I'm gonna remove those. I'm gonna remove all special characters, including hyphens. Maybe we'll fix it later. And we're only gonna leave alphanumeric characters. Here. So in our tokenize, we actually have to go through and remove all alphanumeric characters. So I'm gonna do a text dot where, I believe. And so it's gonna be on our characters. And we're gonna say ch dot is alpha dot is alpha. Ooh, is there no is letter? Okay, we're gonna go with is letter. I was looking for alpha. I don't know why I did it. So if it is a letter, we're gonna keep it. And then to split, we can't do a split on that. So I'm cheating at like, we might do a thing where we go ahead and we break it out. Notice this is gonna remove our spaces. So is a letter or is white space ch. So we're gonna keep it if it's a letter or if it is white space. And I'm gonna cheat a little bit. We could optimize this if we needed to. All right, so I'm gonna do my text is gonna be equal. If I do to array, shows how quickly a simple I becomes. Wait, absolutely, Smab, absolutely. Does line break count as white space? I believe so. We'll find out. I believe it does. If I do a toString, let's do a join. String.join here. We're gonna join. Can I do join like that? Yeah. So is this gonna join it the way I want? Here, we gotta test this out. String text equals trying to type is alphanumeric box. Yeah, I think that might have been what my brain wanted to do. I only want to keep characters. We're gonna remove numbers in this case, like this, kind of because line break is a slash and yeah. So I think so. We gotta kind of test this out, right? I don't like what I've got here. Now, one giant string. Do I have to put a? Okay, so I do have to put a space here. That's what I want. So I want one giant string, and then I split it. Is there? Unless there's a split, because it doesn't. Oh, there is a split. Hang on. Oh, that's because I'm inside of the join, right? So I don't want to have to write an aggregate like this. So this is gonna give me back just this is IEnumerable of type char, all left filtered like that. So this gives me back IEnumerable. So now I have all the characters, and I basically want to split them on white space now. I do want to split them on white space. Is there a nice link function that like has us break it out group? Is there a group by? Groups the elements of the sequence according to a specified thing. I don't know if group by is what I want here. I don't want to have to worry too much about this. Again, this is a weeds in the weeds detail here. So I'm gonna actually just go ahead and join these. I'm gonna join them so it's one big string. Join string.join with no spaces in there, and then I'm gonna split this. So string text. So I guess I can do text like this. Filtered text, and then we'll split the filtered text. So this is not the most efficient. So I'm gonna come out here right now and say this is not the most efficient. You could optimize this further, but it might be good enough. So we actually have to pass over the text once, twice. It's still O of n. ToString. Does ToString on the enumerable work that way? It's our filtered struct ToString. This is gonna print out that it's an IEnumerable. I believe this will display that it's an IEnumerable unless I turn it into a string with the join. All right. So we're gonna filter the text and then we're gonna split it like this. I believe this will get me back what I want here. Let's try it. Let's try it. Topologist, yeah, capital D dog and lowercase d dog would be two different words. So should we lowercase everything? Maybe we should lowercase everything. Let's go ahead and do that. I think that's a decent idea. Let's lowercase, because it depends. Do you want that to count or not? Do we want that to count or not? To lower, we could do it this way. Now we'll have only lowercase. So if we filter it out, it gives just lowercase like that. So we've taken our text, we've filtered out all of the special characters. But yeah, there's like to do. We could implement this further. What about hyphens? Is this how we spell hyphens? What about hyphens? Right? Can we do it in a single pass? To lower invariants, what's the difference? Returns a copy of the string object converted to lowercase using the case rules of the invariant culture. So it's specific. It's specific to your locale. Is that correct? To lower. That makes sense. Great point, Smab. Thank you. Points. Add Smab, 50 points. Good. Oh, it's the opposite. It doesn't. It ignores the locale. It ignores the locale. Why would I want to lower invariant versus to lower? Let's take a look. To look in C#. To lower invariant is a method. Returns a copy of the string invariant. The following example demonstrates a string array in a single listed language. The toInvariant method is used to populate the elements of a parallel array. The method is used. Yeah, so if you have things like this makes sense. You don't want to avoid it. So you know, there's this idea of is data munging, where you have this data and you sort of gotta clean it up, shimmy it out, get it working in a possible way. And you never know what your user might give you, right? So Smab, excellent suggestion. Thank you for sharing that with us. Nomad Labs, how are you? Thank you for following me today. I hope you're having a beautiful day, Nomad Labs. I'm so glad you're here with us on this beautiful Tuesday. Thank you for joining us. We are in the process, right, of talking about hashing, hash tables. What the heck are we doing? Using it to create efficiency. All right, so we've pulled out these tokens here. And so now we know all of we know all the words that occur inside of this. Now we just want to know how often they occur. How often do each one of these occur? And then maybe we might do a thing where we sort it by the biggest. But we want to know at the end of the day, given some text, where'd my remarkable go? Given some text, I want to create a histogram that says the most frequent words. What is the frequency of these words? Okay, so we've gone through. This builds out our unique words. And then you might say, okay, well, now that I have the unique words, I can go through each one of these and I can count them. We wrote another function here. Text analyzer dot count words. And we're going to count given our text. This is interesting. Text. All right, so this is where some weird efficiencies come in here, right? And we say int count equals, and then we can do the following. Say console.writeLine, in this case, token, and then our actual count here. So this will actually do what we want, but then we're going to talk about like, why is this so inefficient? It's like painfully inefficient, I believe. So let's go ahead and check it out. All right, it's painfully inefficient, but notice the computer's still super fast. It's still super fast here. JD, thank you so much for the doi. How have you been, my friend? Welcome back to the stream. We're talking about hashing today. And so why is this so bad? This is like horribly inefficient. The word the shows up 40 times. Magical shows up 5 times. Low shows up 2 times. The empty string shows up 9 times, so I think that is the number of returns we have, spaces. Computers are insanely fast either way, yeah. But as we get longer, how many times are we having to count all of things? Yeah, I think there's 9 line breaks, topologist, I believe so. Polia Prague, Polia. Thank you for following. Thank you for following me today. Polia, how you doing, my friend? Welcome to the stream. Java source. I mean, when I started trying to make games 13 years ago in Java, people were telling me, you are crazy. Thank you for the nice, Corpless. Thank you for the nice. In the end, does it matter that much? Well, as your data grows, yeah, it does matter. It does matter. If we wanted to see how many times, all right, so if we want to see how many times we're doing something, it's like really, so like in this case, can I do it? It's really slow. But nanoseconds. But as our data grows, let's imagine I wanted to do a whole book. Let's Let's imagine that my text here was even longer. Let's do it. Let's slow this down. Let's make it long. Time. If I add in a time on here, time. You can tell me. Remove empty strings. So it's taking one second, almost two seconds. Nobody's got time for that. Smad is suggesting split. If we do that, then I have to do this new char array of 0. String, what would it be? Split options, remove empty entries. We could do it this way. Let's make sure that works the way I want. But would it be faster on a more expensive machine? Yeah, but it slows down exponentially as our data grows. It gets slower, like crazy slow. So let's see how big of a text we can do and still do it in like 30 seconds. How big of a text can we do and still have it be done in 30 seconds? So I'm gonna get rid of this right line. Our slowest thing right now is the right line. But let's do a bigger text. Let's find a bigger text file. Let's go to Project Gutenberg. Let's see if we can download a whole textbook and do it. Let's see if we can download a whole textbook and do it. The Second Adventures of Uncle Wiggily. I've never heard of this book, but let's get the text version, plain text version. All right, we're gonna take the Adventures of Wiggily. The Adventures of Wiggily. We're gonna do an analysis of it. New file, Wiggily. Boom. This whole file. This is actually a relatively short story. This book is not long enough. We need a longer book. This book is not long enough. Let's see. Book of the Kansas University Science Bulletin. Let's see if we can find a bigger book here. Let's search for Dracula. Bram Stoker's Dracula. Let's get the plain text file here. Boom. We're going to load that in. Now, let's save this file. Rename. Dracula. All right. When we run this is where the efficiency comes in. All right. I don't even know if this will finish. 2 seconds. Oh, no. I got to change it to Dracula here. I got to change it to Dracula. My computer, my keyboard's not working. Am I still streaming? Am I still here? Priscilla, thank you so much for the follow. Priscilla, thank you for following me on this day now. Priscilla, I'd like to welcome you. I'm stalling 'cause my keyboard stopped working on this editor. My keyboard isn't working and I don't know why. All right, it works in my terminal. Let's try reopening program.cs. What's going on here? Reload. Priscilla, thank you so much for the follow. Welcome aboard. Welcome to the crew, my friend. Happy to have you here. What's going on? Dracula. Why can't, there it goes. Dracula.txt. Let's see if this will even finish. Will this even finish? Java source, no, I was planning to do this anyway. Let .NET run, I don't know if this will even finish. Let's time it. .NET run. So the question is, can we do it better? Well, what is the error I got here? Dracula.txt, file not found. Dracula. This is just not in the right folder. Hang on, folks. Got to put that with our text analyzer. Text analyze. It's long without printing words. It's just like what you're, so it's interesting. This is why benchmarking is interesting. This is insane. This whole thing's driving me nuts. It's so fast right now that 1 second could just be my system hiccuping. Like, so there's a million things actually that your computer's running all the time. And it's like, which one is it gonna pick there, right? So which one is it gonna pick? We're gonna, hang on, something's going on with VS Code right now. And so it's doing all these switching. So when you have just like a 1 second difference, in fact, there's like 0.4 seconds, it's like, what is really happening there? It could just be it took it a second to boot up. 1 second. I'm trying to get my VS Code to open back up here. Apparently there's a rank command. I didn't even know that existed. All right, open a hash table solutions here. I really just want to move. For some reason, VS Code doesn't want to move that file for me, so I'm just going to move it in my terminal. MDS, did that kind of answer your question? I'm curious if that was any help at all. .NET run. Couldn't find, all right, CD, I can do it. You guys gotta believe in me. Oh my goodness. All the ranks here. Unable to run, ensure that your .NET run, .NET, oh, I'm in the wrong folder again. CD text analyze, did I move my Dracula file here? Move. Hash table, Dracula here, .NET run. Okay. Okay, so here we go. We're gonna time this. I don't even know if this will ever finish. This might be so inefficient that this will never finish. We're gonna leave it running here for a moment, but we're doing an analysis of the entire, of Bram Stoker's Dracula. I don't think this is gonna finish. It's running really long. Yeah, I think this is going to take a really long time to run. We might actually just go ahead and take our first break and come back and see if it ever finished and see if we can clean it up here. But yeah, it's taking a really long time to run. And what we might do here, we might add in a benchmark over 30 seconds of her. So apologize there. But yeah, so we're gonna look at the optimization. This is the time. So premature optimization is bad. If all I need to do is analyze bread.txt, that would be fine. That would be fine. Our program would have been fine. But now we're going, oh, this is too big. This is too big. Let me put my bread in here so that we swap it out real quick. And basically, I want to come in at the end. I want to do console.writeLine, and we're going to say writeLine. Found token, sorry, this would be count, int count total, count equals 0. We'll do count here, found, just so we have an idea, count unique tokens, like that. And we'll just run it again just to make sure, time.net run. And with the bread, boom, super fast. So 2 hours of 6 hours didn't matter. Yeah, so this might never, could you summarize text analyze real quick? They never miss, of course. Of course. All right, so we are doing a histogram. The challenge, the programming task we're looking at today is to count, where's my thing here? Write a text editor that builds a histogram of the words that appear. So essentially, we want to loop through, we want to find each unique token in some text and then say how often that word appears. So you can think of it as like a heat map of words. So how many times is the word a, or a frequency count of words here. So for example, in this bread.txt, this was an AI generated program text here. We have this particular distribution like this, particular distribution. The word his appears 4 times, mallow appears 5, on appears twice, rose appears once, as appears 6 times, Elise is the name of a person, and this appears 10 times. So the text analyzer goes through and it counts the number of times each word appears. And so count words is really quite inefficient here. We just showed, okay, well, it looks like it runs really fast, but in this particular document, is short. Computer can do this problem grows really, really big. So we tried to do it on Dracula. Dracula is a lot bigger than bread. Dracula is bigger than bread. And our program, when we tried to time it, it ran and it ran and it ran and it never quite finished. It ran and ran and it never quite finished. And so we're going to look at using a dictionary to solve this problem, a hash table to solve this problem. The inefficiency here, if we look at count words, the inefficiency is coming. I really dislike the new CSharp plugin. Yes, the last count is only from the pass-through. Yeah. So we're gonna look at why this is so inefficient. This is why it's so inefficient. And the problem that we're running to is we have this text. It's this count words function. This method we're using here is looping over the entire body of our text multiple times. The entire body of our text multiple times. But liar, yeah, if we did a benchmark, if we profiled it, we'd absolutely see some issues. It's this count words. It tokenizes this whole thing. So we're gonna look at, and then it goes through each token in the text and counts it. So the inefficiency is coming from count words. And so the question is, can we do it better? Public, static. Ideally, we kind of want to do this unique words and our count at the same time. And instead of using a hash, we can use a dictionary. And under the hood, this is implementing a hash table, which instead of hashing a single thing, it just tells us whether or not it's there. We have that value and a number. In this case, a number can be anything. So our key is the string. This is the word. And then the frequency is going to be how often it appears inside. So we're going to take our dictionary, get us a string, get us an int. And then we're going to change this to frequency. I'm just call it frequency. It's going to take in a text and it's going to produce a dictionary for us. It's going to produce a dictionary for us. Box, thank you. Box, dirt, why? Thank you for following me today. Box, dirt, why? Thank you so much for the follow, my friend. Happy Tuesday. I'm glad you can be here with us. So the idea here is we're going to take our tokenize. I'm going to go ahead and tokenize it here. And we're actually going to loop through. We're going to be looping through, and we're going to do something a little bit different. We're going to say for each string token in tokens. Okay. We're going to do something similar. We're sort of combining the count words and the unique words together. Let me pull these side by side. Let me pull these side by side so we can have them both on the screen here. Unique words here, right? All right, so we're going to write frequency. At the end of the day, we need to return. Again, we're doing an aggregate function. We're doing an aggregate function. Dictionary from string to int like this. Frequencies. Frequency. Okay. Remember, each one of these follows this pattern of an aggregate. We are looping through some data, building something up, and then return it. In this case, we do the count. Count is an aggregate. It's the thing that's changing each time we loop through. In our unique words, the hash set is the thing that's changing. And similarly, in our frequency here, this is actually our dictionary is gonna change, and at the end of the day, we return our frequency here. Science Streams, welcome back, my friend. It's so nice to see you. Folks, if you guys don't know, Science Streams, incredible. Why didn't it let me do that? Shout out, Science. I think I typed just /shout. Science, so happy to have you here on this beautiful day. Folks, if you guys don't know, Science Streams, incredible place. If you like to learn, if you like science, if you like ants, if you like laughing, if you like crazy, fun, good times, and you can't be, and you're insatiable, you cannot be satisfied with knowledge, Science Stream is the place to go. Science, thank you so much for being here. How are you, my insatiable king? I'm doing fabulous. Any day I can wake up and code is a beautiful day. Any day I can wake up and code is a beautiful day. I'm having an absolutely fabulous day here. All right, so this dictionary is what we're gonna build. And we're gonna do, similar to unique words, we have to check, have we seen this token? Have we seen this token yet? And the cool thing about a dictionary, which is using hashing under the hood, is we can check whether or not this has been here before. We can't do contains because remember, it's going from a key to a value. We want to check if it contains a key. And in this case, we're checking if it contains this token, right? So we're checking for this token if it's a key. And again, we have O of 1, mostly O of 1. And when we come back from our break, we're going to actually try and implement our own hash table, or at least some version of it. We're going to use this to look up the contains token. This should be fast. If it doesn't contain it, what do we have to do? What do we have to do? If it doesn't contain it, we are going to add in this token. And I'm going to set it to 0. You might say, well, I should set it to 1. I should set it to 1. I'm going to set it to 0, but you might say we should set it to 1. Thank you for the whoa, JD. Thank you for the whoa. Also, Gabriel, thank you for the follow. Have you met Gabriel Modog? They have followed me today. Thank you for being here with us. Gabriel, thank you so much for the follow. Welcome to the Captain's crew. Welcome to Captain Coders Academy. I'm so happy you are here with us. All right. All right. Hash table, JD. I don't remember agreeing to a content where I'm sorry. I'm sorry, my friend. We're doing our best. We're hashing it up. We're making hash browns. We're cooking. We're cooking with some steam here. Is it cooking? Do you cook Don't steam your steamed hash brown sounds terrible. Actually, don't steam your hash browns. You gotta fry them up. You gotta fry them up. What are steamed ham? That's right, JD. Steamed hams. JD, by the way, how have you been, my friend? I don't think I've seen your stream this week. Have you been streaming this week? It's usually Monday, Wednesdays. Is that right? All right, frequency. Art, welcome back to the stream. So nice to see you here. So we have our free exam. I set it to 0. You might say, well, shouldn't you set it to 1? Shouldn't you set it to 1? Well, maybe. I'm going to do a thing down here. So I don't have to. So we could set it to 1. We could do this. Set it to 1 and then have an else frequency at our token plus else increment. We could do it this way. Maybe I should do it this way. What I was going to do, I think it looks a little bit, you know what? I actually don't mind this. I don't mind this. When we find, if the token's not there, we set it to 1. Otherwise, we increment the token. All right, and so we're now, notice, we've sort of combined these two things here. We have to increment our count. Instead of having a single count, now we have a multiple counts. We map it here. And we're relying on our hash being fast. With a lurk here and a lurk there, here lurk, there lurk, everywhere lurk, Smab. Welcome to lurk mode. Thank you for being here, my friend. I appreciate you lurking. Also, so we have this, and we're gonna see if we can get some speed up here using our frequency. So rather than doing unique words now, you can do a dictionary from string to int. It's our frequencies. Frequencies equals text analyzer dot text analyzer dot frequency, and then we pass in our text here. So you can think of the keys as our hash set, right? And the int as our counts. Int as our counts. Okay. So now if we loop through, no longer looking through tokens, it's going to be frequencies.keys, and we can print it out here. And then count, we get rid of count here. And so we have our token, and we can look up our frequencies of token. So give back our number like so. And then we can say frequencies.count to get the total number of unique tokens. All right, let's check it out. Let's check it out. All right, 255 unique tokens. Is that what we had before? Sorry, I should have checked it out. 1 unique token. I didn't actually increment my count there. All right, so my number is right. So this is now correct. All right. And then we can count how often the same word occurs in the build. Topologist, you're getting ahead of me, but yes, we're going to be able to do a sort here on that and find the most frequently occurring ones, or ones that occur more than once, or one, you know. So what's interesting, so let's see. I'm a little nervous. Because I don't know if Dracula might still be too big. Dracula might still be too big. Oh, I mean, instead of a hash, could we just sort the tokens? Then we can just count how often. Ooh, that's not a bad idea. That said, sorting this whole text is giant. This text is giant. And so the sorting, I think, yes, the answer is absolutely you could. And then you could do one time down. All right. Boom! Javasaurus! Did you see 3 seconds? We got down to 3 seconds and printing it all out. This is for holy cannoli, holy moly, holy cannoli. The Dracula, which just wouldn't finish before with our previous version, 3 seconds. 3 seconds using a dictionary, using hashing, super efficient. Whoa, yeah, increase of 10 billion times, whatever it happens to be. Maybe we should have been right. Basically, an unstoppable problem. That's right, Ubuntu. Good. Thank you for the nice. Oh, folks. Whoa. Thank you for the whoa, Ryan. I appreciate that. All right, folks. All right, so we've talked about the motivation behind a hash table. We talked about the motivation behind a hash table. Why we use it, why dictionaries are so. It's a really, really powerful tool that lets us do really fast storage and retrieval. Really fast storage and retrieval. We're gonna take a quick break here. I have a little bit of bean water left, but I gotta get a little bit more bean water. We're gonna take a quick break. I'm gonna heat up my bean water, get myself a little bit more, take some regular water here. For some reason, my break timer doesn't work anymore. But thanks to whoever came up with hashing, Belier. We're gonna look at how hashing works when we come back. When we come back from break, we're gonna look at how hashing works. We're gonna write our own hash table for strings. We're gonna write our own hash table for strings. We're not gonna implement a full dictionary implementation, but we're gonna talk about how it works under the hood. So hang tight, everybody. We'll be back. Well, while you're waiting, I'm gonna tell you guys, you gotta check out Art Berkless, incredibly talented game developer creating the Warlock's Gauntlet, folks. Well, while you're waiting, I'm gonna implore you to go check this beautiful pixel art based game. Click that Steam, add it to your wish list. Go play the demo, the Warlock's Gauntlet. Art, incredible game developer, incredible human, incredible artist. Not only is Art making this game, Art is writing the game engine for it for learning purposes, and also look how fun this is. Check it out, folks. Captain Coder's gonna take a break. When we get back, we're gonna do some quick stretches. We're gonna answer your questions. We got a few questions here already. If you wanna get your question added to the queue, exclamation point Q followed by your question. We'll be back. Hang tight, everybody. The captain shall return. All right, folks, the captain's back. Thank you guys for hanging tight. Thank you for hanging on. Thank you for being here. We are back. We're going to take care of ourselves, folks. It's time. It's time to get up, get a little stretch in, take care of everybody. Look, the captain loves you, which means you should love you. And if you love you, you got to take care of yourself. And one way we can take care of ourselves is getting up. Oh, my whole bag went, I just felt it. Get on up, get out of that chair, stand up, get that body up, get moving and grooving and taking care of ourselves. We're going to get on up, we're going to take care of ourselves, we're going to do some stretches, folks. Look, the captain's going to implore you. Is employ the right word? I'm going to employ you. I'm going to implore you. Hang on, my camera. Point that down a little bit here. Get a little stretch in, get a little stretch in.
You in the
Come
back,
on,
pay
stand
attention.
on up. We're stretching. Yeah, that's right. Pay attention, Ben. Thank you so much for saying pay attention. Dram, well, you know we're talking about you, Dram. All right, folks, get on up. We got to take care of ourselves. Do a little stretch here. We're going to stretch out our forearms. You guys know it's one of my favorite stretches. Grab those fingertips. Grab those fingertips and pull on back. Roy Koo, welcome back to the stream, my friend Wavy. Wavy's worried about being late. Don't worry, Wavy. We're going to pull out and stretch across the forearm here. If it hurts at all, stop. You don't want it to hurt. You want it to feel good. You want to stretch it out. Pull on back on those fingers so you got it in there a little bit. Great time in for stretchings, Lance. That's right. Welcome back, Lance. How the heck have you been? Roiku, how have you been? In Wavy, how have you been? It's okay, my friend. You don't have to be here exactly on time every time. You don't have to be here on time every time. I just appreciate you being here when you can and that you enjoy it. Look, I'm doing this. It's an interesting thing. Go ahead and roll that wrist down. Roll that wrist down. Oh, I'm doing this because I love doing it, but you guys make it so much fun to do. Grab those fingertips, pull down, stretching across the top. This time, if you feel any pain again, especially in the wrist, you don't want that came in here. Rookie, I just came for the stretching, otherwise I'd not remember to do it. That's right, Roku. Welcome. I'm so glad you're here, my friend. I'm so glad you're here. Taking care of ourselves, loving ourselves the way we deserve to be loved. Oh, feels good. We're gonna be checking out your questions. If you have a question for me, you want me to talk about it, talk some on stream, feel free to ask me now. Oh, I've been doing good. Had a heavy day at work, but I'm off for 2 days and get to focus on my new game. How have you been? How has school been? It's been wonderful, Wavy. I've been doing so great. Go and roll that wrist out. Roll that wrist out. We're going to change sides now. Grab those fingertips, pull back, get a little stretch in. Wavy, so for anyone who doesn't know, I am Captain Coder. Captain Coder is me, and me is a computer science educator. I teach computer science and program my full-time job. Teach computer science and programming at a school ages 10 to 14. Young people, inspiring the youth. It's so much fun. I love it. We were on summer break. We went back last week, so this is our second week of classes. In fact, this is it's our first Tuesday. We went back on Wednesday. Essentially our first week back. It's been so wonderful. I did actually know how much I missed it. Go ahead and roll that wrist out. Oh, we're gonna go the other direction now. Pointing those fingertips down and pull. I love teaching so much. I didn't realize quite how, I don't want to say I was depressed, but I think I was feeling a little bit down just because I was missing teaching, and now that I'm back, oh my goodness, it's so much fun to be back, so much fun to be teaching. I love my students so much, new faces, old faces, and I get to teach a music class this year. I'm so excited to be teaching a music class. Go ahead and roll that wrist out. Oh, doesn't that feel good? Doesn't it feel lovely? All right, folks, we're going to do some shoulder rolls next. Go ahead and take those shoulders, put them up, back, and down, and we're going to roll them back. 2, 3, 4, with the elbows. 2, 3, 4, full arms. 2, 3, 4, roll them forward. 2, 3, 4, add the elbows. 2, 3, 4, full arms. 2, 3, 4. Oh, shake it out, shake it out. We're gonna do some head rolls next. Get those rolls in on those heads, on those necks, on those rolls. Go ahead and put that head down. And I am going, what is this? Would this be clockwise? I think this is clockwise. I'm not sure. We're just going to roll this way 4 times. And we're going to do the old switcheroo and roll back the other way. Oh, it feels lovely and wavy. Tell us about your new game prototype. I played Pumpkin a little bit. Really, really great start to your game dev. I think you've only been doing game dev for like a week. Is that true? The other direction. 1. 2. If you're getting dizzy, go ahead and stop. You don't want to get dizzy. 3. Last one here. Oh, yeah. Bring it on up, folks. Folks, thank you so much for joining me in that stretch. Clockwise for you or for us? Isn't clockwise the same? That's the whole point of clockwise. Is it the same? I don't know. Look, counterclockwise, look. Art. It doesn't really matter. It turns out it doesn't matter. It doesn't matter which direction it is. All that matters is that we all know how to read time. Because time is relative. And relatively speaking, it's true. Julian, welcome back to the stream. It's so nice to have you here, my friend. So we got a couple questions. Here. Let's pull them up here. Let's take a look. Thindle asked, is P equal to NP and why? Thindle, this one's tough. If I could answer this question, I would win $1 million. This is an open question in computer science. There's this idea, if you look at the theory of computation, I wish I had my theory of computation, the field of study called the theory of computation, where you talk about classifications of programs, classifications of algorithms, how long they run. And one of the things we talk about is like this big O of n squared, these things. So the question is, O of n is called linear time. There's this class called P, polynomial, P versus NP. And so the idea is that we have there's actually many different classes of problems, but we have a class called P and a class called NP. P, what was it called? Non-deterministic polynomial time. So it turns out these problems are hard problems, and it turns out most of the interesting problems we try and do in computer science happen to be these NP problems. But we cannot prove. People said, well, it turns out you can like compare problems. It says if P problems that fall in the class of P, we're very good at solving them. And so there's actually this open question of P, we're pretty sure that P is not equal to NP, that they're not similar. P is not equal to NP, but no one's actually proven it. No one's written a proof to say. And it's an unsolved computer science problem. And I think there's currently like an award. If you're able to prove it, you'd be amazing. You'd win some pretty incredible prizes. So Thindle, thank you for your cheeky question. The answer is P equal to NP. Probably not, because if they were, we would probably know that in my mind, it's much more likely that they're not equal. It's just hard to prove why. Great question, Thindle. Thank you for asking. Thindle, for asking a beautiful question. 50 points to you, my friend. Thank you for asking. Ben asks, can you see my 2 polylow characters in Showcase Saturday? I'd be happy to look at them on Showcase Saturday. Let's see if so just so you know, folks, we do have a Showcase Saturday coming up where you can share your work, show off what you're working on, and help and have a beautiful time. It was so successful, our last Showcase Saturday, that we're going to be doing it again next month. I'm super, super excited for it. But yeah, here's low poly sleepy boy Ben. Low poly sleepy boy. Let's open this. Let's open this up. Open in browser. Why did that not work? Hang on, let's try that again. Open in browser. There we go. This is Ben the developer. The question is yes. Can I? Yes, I can. Will I? Yes, I will. Ben, thank you so much for sharing. Ben the developer, 50 points to you. This is Poly Sleepy Boy. Is this done in Blender? Very cool. I've been doing a little bit of Blender. Oh, and then you got a rubber ducky as well. I got a rubber ducky. Why does it open in my other browser? That's so weird. I didn't even have anything selected over there. That's very, very weird. Beautiful rubber ducky. Low poly ducky. Rubber ducky, you're the one. You're low poly and you're so much fun. We love this rubber ducky. Ben, thank you so much for sharing it with us. Beautiful job. I've been doing I actually finished a low poly Blender course. I want to get better at Blender. There's lots of tools in it, lots of things you can do. It's amazing. Wavy, no worry about the novel there. I'm sorry, I can't say it. Where it says, maybe I'll have enough prototype products to be able to share with Showcase Center. I hope so, Wavy. I'd love to see what you've been doing. Ben, thank you so much for sharing again. Beautiful stuff. Beautiful stuff, my friend. Moon is asked, I have never taken a breaky poo. I'm assuming I said breaky poo earlier. Like, when we're on a breaky poo, we'll answer some questions. That's probably what I said. That's a little, my band director, my high school band director used to say things like, let's have a little, we'll take a breaky poo, we'll have a lunchy poo, we'll have a thisy poo, a thatty poo. It's just a cute little add-on you add to the end of anything, apparently, that makes it more cute. More cute. And Moon is. I'm sorry. You might want to see a doctor if you've never been able to take a breaky poo. It adds in some relief, my friend. Adds in some relief. Sorry for the toilet humor, folks. I apologize. Well, I guess I'll just show myself out. No, I kid. I'll try and refrain from toilet humor. I apologize. Corvus asks, do you like Vim? If so, do you use it? Corfless, excellent question. I'm more of an Emacs person. I used to use Vim exclusively, and then in undergrad, a professor introduced me to Emacs. In fact, it was a functional programming class, and we learned about Scheme, which is a Lisp-like language, and Haskell, and got used to the tools, and I just kind of fell in love with Emacs. And I think it was because Emacs Lisp, you can customize the editor. using Emacs Lisp, and I think I kind of fell in love with it that way. So I don't use Vim these days. I don't, I wish I could remember. I remember all the hotkeys. I don't remember them all, and I struggle in Vim these days. And then Wavy asked an additional question here while we're on the other one. I was pulling these over here so I can pull them out sideways. Wavy asked, I'm trying to build a simple prototype at the moment, but while my girlfriend learns pixel art, I need filler sprites and can't figure out how to splice this sprite sheet. It's grayed out for some reason. Any help? You want to send the sprite sheet? Wavy, have you sent the sprite sheet somewhere? Where's the sprite sheet? Where is the sprite sheet? I need the sprite sheet to check it out and help you out with it. Need filler sprites and can't figure out how to splice this sprite sheet. Post a sprite sheet on the help form. Yeah, please do. You should be able to post links here as well, but let's try that. Wavy. This particular question in general, what I'll tell you to do next time is do it in the ask for help forum on Discord, and then say, hey, I asked a question on Discord, and we'll look at it. Any Mortal Kid, it's so nice to see you. How you doing, my friend? I hope you're doing well. Let's open up this link. Open it up on my other browser here for a second. Hang on. Just to be safe, just for a safety poo. Protagonist character, free pixel art. Okay. So this is our protagonist character, free pixel art animated. So I'm assuming you've downloaded it. Download, no thanks, just take me to the download. Download here. All right. Open this there. I'm gonna open this up in GIMP. So you are saying, so this is specifically in a Unity project, I'm assuming. Let me open up a Unity project here so we can test this out. Open up a Unity project so we can test it out, Wavy. Might take me a second to load this up, but let's open this up in the GIMP as well. Sometimes sprite sheets, you have to do a little bit of editing on your own. But we'll check it out here. I'm assuming that we just need to slice it a little bit better. Let's go to my project, this one here. Keep. All right, so we have our sprite sheet like this. It's a cute little sprite sheet. And then in Unity, we're gonna have to slice this thing up. If it's not letting you slice it, any Mortal Kid, you probably have to set it to multiple. That's probably the first thing. And there's a couple other things you're gonna wanna do for pixel art in Unity, because by default, there's compression on the image. And so we're gonna want to make sure that the settings are not compressed, so that you actually get the pixelated part of it. Point no filter compression, none. Yes, exactly. You're the one that has the most viewers, but no partner on my front page. So I'm here, Alexander Online, Alexander Online. Thank you for being here, my friend. Yeah, that's correct. I'm not affiliated. I'm not partner. And that's okay. I'm glad you're here, my friend. I've chosen not to be affiliated. I don't want to have to play the ads. Yeah, so this is GIMP. This is GIMP, not Icebrite. How did you get this screen? This is in GIMP. So Unity is loading right now. But Alexander, how are you, my friend? Am I saying your name right? Alexander? There's no, I want to, my brain wants to say Alexander. Oh, apparently I have a bunch of Unity things open already. That's really weird. I must have accidentally opened a bunch of these. Okay, let's come into our sprites here, and we're going to create a folder called demos, slice demo. And I'm gonna put this animation sheet in here. Okay, and I think I have mine set up to actually import in a special way. Yeah, so mine did this. Over here in my, let's switch this back. By default, it's gonna be all of these settings here, compression, normal, okay. So by default, it's this, and you probably clicked on your sprite editor, and it's kind of fuzzy, and it won't let you click slice. It's grayed out. This is what you have, Wavy, I'm assuming. So what we need to do is this sprite mode over here. Come on. Why won't my, there we go. The sprite mode over here where it says single, it's saying this is a single image. This is mostly a texture. We're gonna set this to multiple and then click apply. This will tell us that this thing is actually a sprite sheet that we can slice. I have some other default settings as well. And what I'm gonna do is I'm gonna actually set it my cell count, size, whatever it happens to be. And it looks like I have 1, 2, 3, 4, 5, 6, 7, 8 columns. And 1, 2, 3, 4, 5, 6 rows. All right, and I'll click slice. And this one set up looks pretty good the way it had it set up here. And it sliced it for us, okay. The next thing we're gonna do, so you'll notice, let's go ahead and save this, is that these guys are super tiny, and they're really, really fuzzy. They're tiny and they're fuzzy. I'm gonna set this so that the number of pixels per unit, so it's small, I'm gonna set it to 32. What this is gonna say is that the pixels per unit is defined, so one movement unit on the screen. So here, if I set this guy at 0, 0, and I move this guy, let's move him over a little bit. Can I turn off my gizmos? How can I turn, there we go. There's my guy, there's this little guy. If I move him left and right 1 unit, that's saying how many pixels will be in that 1 unit. This means 1 unit of space will be 32 pixels. So if you want to adjust this a little bit more, maybe make it a little bigger, you can adjust it this way. You can also scale it up. I prefer to do it this way and have all my pixels be consistent across. Now it's fuzzy. The fuzziness is coming from this filter. And so if you set this to no filter, it's gonna do no filter on it. And now it's a little bit crisper. And then there's one other thing, the compression here, we want to set to none, as the compression will actually cause colors to disappear. So in this case, the colors didn't change, but if you have a more expressive image with lots of different colors, this compression will actually get rid of some colors. It'll merge colors together to make it smaller. If you set it to none, that won't happen. So to repeat, we want to set sprite mode to multiple. Adjust your pixels per unit to be based on your game. In our sprite editor, you can now slice it based on that sprite. This particular slice was 8 columns, 6 rows. And we then set the filter to none. This made it nice and crisp. And then we turned off compression so we don't lose color information. Wavy, hope this was helpful. Thank you for asking. And excellent question for asking such a beautiful question. Raising points, add Wavy, 50 points to you, my friend. I hope this was helpful. Now, for some reason, I have 3 Unities open, so I'm gonna go ahead and close 2 of those. This is your game, Pumpkin. We were checking that out last time. All right, beautiful. All right, folks, let's see. I don't think anyone else asked a question in the meantime. Let's double check that. Let's double check that. Questions, no additional questions. All right. Thank you guys so much for your questions. We're going to hop back in here. We're going to talk about hash tables, hashing, dictionaries, and why they're beneficial. So our non-hashing version of this, we wrote a little program that does text analysis. We're creating a histogram of this. So given a text file, tell us how often a specific word occurs. So how often does the word sum appear? How often does the word exclusion appear? How often does the word Dracula appear? And we wrote this using a dictionary, and this uses hashing to make the lookup and storage very quickly on the hash element. We're going to talk now about what is actually happening under the hood, why this makes so well. Yes, that's right, Art. It's an educational stream, my friend. We're learning, we're coding, we're growing together as a crew. Art. We're doing the best we can. Okay. So what we want to look at now, I'm going to create a class here called hash table. Hash table. And there's sort of under the hood of a hash table, we're just an array. It's just an array. An array gives us fast lookup times. So we need a way to convert something. We're going to use strings. We're going to use strings for simplicity. Public. We're going to call it a hash. So I want to hash that. No, we're not going to use hash. IEnumerable string keys. All right. So we're going to have keys inside of our hash table. And then we're going to have values. So we have a thing that will give us back all of our keys if we need them. We need to be able to look up the keys that are inside of this thing. We also need to have a function that gives us back a value. In this case, this hash table, for simplicity, our hash table has keys that are strings and values that are integers. All right. And it could be an object. We do a hash table type T and have an object. For our version, we're going to use integers as our value. So we're going to have a thing here called public void insert. And it's going to take in a string key and an int value. This is the value we're going to store. We're going to take a key and we're going to store a value. We need a way to retrieve. In some languages, we call this put or set. Put might be a better one. Insert and then get. Public int get. And it's going to take in a string key and it will return. And we'll throw not new, not implemented exception for now on these. Okay. And so given a key, give it back to us. And we can just ignore that for now. But this is the basic idea. We want to be able to insert something with a key and look up something with a key. And then also sort of check, does this thing exist? So how do we do this quickly? We need a way to hash a key. So we have to have a function that takes our key and turns it into a string. And then at the end of the day, we can actually have like an array. Values, private values. Of the values. And the idea here is that we'll have some function, private, and maybe it could be a public function as well. Public int hash key, like this. And this is going to return to us a integer that we can use to index this thing. We can index inside of our values. And maybe I'll call this data. Table. Table's a better name. So I actually have a table. So given a string key, we can look it up in our table. So when we insert just sort of comes kind of. And you're gonna see that there's a little error here in here. Int hash is equal to our hash key. We take our key like this. And then we'll do table of our hash is equal to value. table of our hash is equal to value. I could swap this out for a generic type here, and we can say this is of type T. We can insert T's like this. This is still an int, and then our table here. So we have a hash table that stores things. It goes from keys to other things. So we need something that converts our string to an integer and then looks it up. What's an issue here? What do we see? What do we see? I see an issue here. What happens if our hash is out of bounds? We actually want to say, well, and then limit where this thing can be inside of this table. We could do it here, table.length. If we use modulus, modulus says, what is the remainder? So if you're not familiar with modulus arithmetic, this is saying this will be a number between 0 and the length of this, depending on what it is. And we can draw that out a little bit here. So modulus is just doing long division. So that's interesting. This autocomplete's super interesting. It wants me to do this thing. Topologist, can we assume the hash is unique? This is where Fuel Snabble was getting to earlier, saying, well, if the hash here is dangerous. The hash here is dangerous because if it's not unique, what do we need to do? Yeah. So therein lies an issue. Therein lies an issue. But let's look at what mod looks like. 0 mod 10. So this is 0 divided by 10. There's no remainder. 0, 1. Let's go to 5. 5. Mod 5 goes to 1. 2 mod 5 goes to 2. 3 mod 5 goes to 3. 4 mod 5 goes to 4. 5 mod 5 goes to 0. And this thing repeats as we go up. This thing repeats as we go up. 6, 7, 8, 1, 2, 3. Yeah, so when we mod this thing, it's not that the hash isn't unique, it's that we don't have infinite size on our table. We don't have infinite size on our table. And so what you might do is you might say, okay, well, my table, I'm gonna make my table start out at 1,000 things, 1,000 things, and then we're less likely to have a collision. We're less likely to have a collision. But really, there's an interesting thing here. Well, you can still have collisions. You can still have collisions. If two things hash to the exact same index, they're not even hashed to the same number, they're not hashed to the same index, so we have limited space, they are gonna occupy the same space. So we can't actually have an array of these things. We actually end up with what's called a bucket at each index. We have a bucket at each index. So I'm gonna use a list for this. So we actually have, and this is a little bit interesting to look at, we have a list, an array of lists of t's. An array of lists of t's. Let's draw that out real quick. Let's draw that out. Let me pull up my remarkable here. And so the idea is we are going to have some collisions. We're going to try and keep as few as, hopefully have as few collisions as possible. We don't want a lot of collisions. We want, ideally, there's something called a perfect hash, which says there would be no collision. It turns out that's really hard to do. Turns out that's really hard to do. But we're going to do our best. We're going to do our best. Jedi! I'm actually a Jedi. Welcome to the stream. Welcome back. How the heck are you doing, Jedi? I'm so glad you're here with us. So the idea here is we have an array, hash table is an array of buckets. And oftentimes the buckets are implemented as lists. And so the idea, let's say we have 10 slots, 1, 2, 3, 4, 5, 6. Let's say we have 1, 2, 3, 4, 5, 6, 7. Let's say we have 7 slots, 7 slots. All right. We have 7 slots like this. Internally, we actually have a list. And the idea is these buckets should be as small as possible. If you have a good hash, if you have a perfect hash, the list will never get bigger than 1. But the idea being here, if I put in 2 things that hash to the same, let's say that we have a bad hash. We're going to do a hash. We're the first one, right? Hash A, B. We're going to say that this one maps to, AB will map to 101. And BC is gonna hash to 200. This is why I wanted it to be 10, because it'll be easier for my brain to think about. 6, 7, 8, 9. If we hash by 10, this will be 201. Right. This, even though AB and BC hash to two different things, when we mod it by 10, they are going to end up in the same bucket. The same bucket 1 here. End up in the same bucket. So you have AB and then BC. They're in the same bucket. And when we go to do a retrieval, this is the important part. When we go to do a retrieval here, a bucket of love, Snabble, that's right, a bucket of love. When we go to do the retrieval, when we look this thing up, we actually will come into our bucket, and then we have to iterate over our list. We actually have to loop through our list and say, which one of you are these? Are you equal? So we take our hash, we know where to look, and then we do a compare. And then we do the compare. We check. So now I come in and say, find AB, right? Well, let me do BC because the order I put it in here is important. Find BC. All right, find BC. It gives us back this. We know which bucket to look in. We look in bucket 1, and we say, are you BC? Nope. Are you BC? Yes. What is the value that you're associating? So we need these entry lists. We need to store these entries. Lapsus, hair lapsus. Let me know if I'm pronouncing that correct. Hair lapsus. Welcome to the stream. Thank you for following me today. Thank you so much for the follow. Happy to have you here. So the idea here is that we actually have a list of type T's, and we actually, T is the thing we're storing, but we actually also need to be able to check the key is there. The key is there. So we actually have a list of string, comma T's. Close enough. I'm glad to hear it. We have a string, comma T's. So we often, these are essentially our entries. These are the entries that we have here. And so I'm going to write a little struct here to be our entry. So we have our hash table, because I don't want to have to keep writing this tuple this way. Exactly, topologists getting a little complex. Let's break it down. Let's make it a little simpler. So I'm going to write a little class off to the side and make it an internal class. We're going to call this our hash table. I'm going to just call it an entry. All right, so public struct entry of type T, and this is going to be, it's about as simple as it gets. Public, and this is going to be an internal, and maybe we'd make it public, internal, and this has two things. And we can make it, we can actually make this a record struct here, and it's going to have a string key and a T value. All right, string key, this is our lookup, and then a value, key value. Art says, I seem to recall that you, in some cases, on collision, just hop forward in the hash table until you find an M slot rather than having a buckets. That is absolutely a way to do it. That is a way to do it. We're going to do the bucket method. We're going to use the bucket method. But yeah, you could, so Art is suggesting that that's a good option as well. In fact, that might be a better option. I usually do it with this list thing here because it's just a little bit easier to implement. We're looking at implementation here. So Art is saying, instead of using a bucket like this, right? Instead of having a bucket here, says, why don't we instead, and this is an absolutely valid one, if this is already full, just go to the next spot. Just go to the next spot. Because it turns out you're gonna have a lot of empty slots here. We run into a challenge of, well, what if something is in 5? So ideally you try and have a few collisions, but you might boom, insert. So you might say, well, my bucket is the empty spaces that come after. How would you make an effective immutable hash table? Immutable hash tables insertion is pretty slow in general. Yeah, so immutability means we're not going to be able to do inserts. You're not going to be able to do inserts. Hash table for pulling things out, and Snabble, maybe I'm wrong here. You could use, there's something called lenses, where you can do some fancy things there, but immutable is implying when you do insert, you get a new hash table back. And so You could do, there's this, in Haskell, they're called lenses. There's this thing you could do. It says, well, now we have a view of the table underneath. Snapple, that's an excellent question. That'd be fun. I've never implemented an immutable hash table, an efficient immutable hash table. I think that would be a really fun thing to do, Snapple. Yeah, so you'd have to, essentially, your hash table is sort of like added on top. It keeps adding an entry on top. I think you could do it efficiently, but it'd still be tough. Yeah. Yeah, so I'm doing it, this bucket thing. You could treat it so that each slot, if there's empty slots after, you treat that as the bucket. And then if you get full, what would happen is if we go to collide things in here, you tend to say, okay, well, now I'm going to go ahead and build up you have too many collisions. We need to rehash. We have to rebuild it. So when we did dynamic arrays, thank you for the woe, Julian. Thank you for the woe. I'm so glad you're here with us, my friend. Okay, so we have these entries. And so rather than being a list of these, we're going to be a list of entries of type T. List of entries of type T. Entry of type T. Like that. So we have these list of entries. These are our buckets, and it's an outside array. We're going to start with 1,000, and essentially, when you start getting full, when you start having lots of collisions, you do what's called rehashing, like we did with dynamic arrays, where you say, okay, well, we need to make our table bigger so that we're more efficient. We won't be implementing that today. And now, though, when we do this insert, rather than inserting a value, we're actually going to insert an entry. And the entry is our key, comma, value like this. But we can't just enter it that way. Gilgamesh, can you talk about caching? That's essentially what we do with hash tables. Hash tables are all about caching data. All about caching the data so we can access it earlier. And Gilgamesh, welcome back. We actually did that with our text analyzer here. I'm going to try not to get too distracted, but Gilgamesh, use Q. Use Q here. Add that to my question queue, and I'll come back to it because I think it's important to talk about caching. That's essentially one of the things that hash tables and dictionaries are fantastic at doing, caching the data, and it is why we got such a speed up. It is actually why we got such a speed up with our text analyzer. We went from basically having an implementation that would never finish or take minutes to days to finish down to seconds to finish. So I'm happy to talk about that if you add it to the queue so I don't forget. Thank you. How do we do caching? Beautiful. Thank you, Gilgamesh, for adding that question because I'd love to talk about that. Okay, so we have this hash. We're going to do it this way. This is actually going to give us back a list. It's going to give us back a list. Stabble, that's awesome. Thank you for sharing that. And if this is the first time we've seen it, remember, if this is the first time, if there's nothing here, we need to actually add a list into the spot. So we actually need to check, is this null? So I'm going to pull it out here. This is going to be a question mark. It's going to be a list entry of type T. It's technically a question mark. Of bucket. So we go find our bucket like this. All right, so it's gonna give us our bucket back. And I want to check, this question mark says this thing can be null, because it could be. Say if our bucket is null, we actually have to create a bucket. We have to put our bucket there. So in this case, our bucket's gonna be equal to, not bucket, our entry. This position, we need to update it. We need to update it to be equal to a new list of our entries. So this is our new bucket. We put a bucket there, and now we can insert that thing into that spot. And I'm gonna say our bucket happens to be equal, I'm gonna do it this way. I'm gonna make our bucket equal this. And then I'm gonna assign that slot in the array to be the bucket. And this is just so that I can reference it down here when we exit the body of this if statement. Now our bucket, we can say, okay, now I want to add a new entry. And our entry happens to be our key value pair. like that. So we add our key value pair, and we could construct that up above. But given a key and a value, this is how we insert it into the list. Maybe John, maybe not, but maybe John. Welcome back to the stream. Long time no see. I hope you're having a beautiful day. Good morning, good afternoon, good evening. In fact, good morning to you, my friend, wherever you happen to be. Cool. Art, I don't know exactly. I might have missed something. This is like the round robin code. Yeah. Art, yeah, we're working on. We actually, Jonas, Red Cabin Games actually finished the last turn yesterday. I think I'm looking. I haven't looked. Mooniz, are we waiting to look at that? We might look at that this weekend. We'll see. So this will add it into our bucket here and adds an entry. There's a bug here. There's a bug here. There is a bug here, folks. There's a bug here. Let's look at this. Let's pull this to the side, and we're going to see if we can analyze the bug. What's going to happen here? What's going to happen here? Does anyone see the bug? Corey L. Weathers. Corey Weathers, you are welcome. Welcome to the crew. Corey Weathers, welcome to the crew, my friend. What is the bug with this insert? Let's think, what are the cases that we can work through in our head? What are the cases here? We insert a key and a value, key value, and we just add it to the end of this list. We just add it to the end of the list. Can we think of a case where we can kind of break this thing? Can we think of a case where we can kind of break this and we do an insert with our key here? What keys? There are two calls to this to demonstrate the bug. Two calls to this to demonstrate the bug for insertion. What are two calls we're going to make to insert the bug and break it? So what happens if I use the same key twice with two different values? So I'll do the key AB. So I'm going to do an insert AB7 and then insert AB8, which is essentially what we're going to do. We're going to take a value, AB, and we're going to count. If I call it this way and I call it that way, this code here is going to actually end up with two entries at that same location. We actually need to make sure that we replace, when the key is the same, we need to find that key and replace that value. So that key we can't get. Collision! Maybe John, but it's a desired collision. It's a desired collision. AB and AB. It's actually saying I would like to replace this. This is why insert is often called put. Because we're not inserting, we're actually setting the value. It's called put or set. This is a desired collision. We want to replace that value. This is why when we use dictionaries, you end up sometimes getting a little bit of confusion when you insert something like, well, that's weird. This is where we do. So I'm going to change this to set rather than insert. And it's going to take the key and it's going to reapply it. So it finds the bucket. It finds the bucket. And then what we need to do is we actually need to go ahead and remove the previous entry, right? We need to go find the entry if it exists in there. So we need to, there's something special. We need to say if our bucket dot contains this entry. So we actually have to say, okay, we have our bucket. We have an entry that we want to find here. We need to see, is there an entry inside of our bucket that already has this key? All right, so we have to go and find the key. For each entries in bucket, is this thing already here? Is this thing already here? Is it the identical key? Not just did it hash the same spot. Is it the identical key? And we're saying if entries.key is equal to our incoming key, then we actually need to replace the value of that entry. We need to replace the value of that entry, right? So we need to actually remove this entry and then replace it. So the for each here is going to make it a little tricky to do this. And we kind of want to instead, if we find this key, we need to remove it. So I'm actually going to use I'm going to use a traditional for int ix so I can know which index we're looking for. We'll start at 0. ix is less than our bucket.length count ix plus plus. So we're going to loop through, and then entry is going to be equal to bucket at index. So the for each loop is just sort of that translation. So this is how we pull it out. Now, if the key matches, I want to actually remove that index. So I want to say in my list, I need to remove the index that, and there's some efficiency things here. So remember, if we want our buckets to be small, we want our buckets to be small. So we're actually going to remove this index. So we go to our bucket dot remove at ix. This is the index we want to remove, and then we're going to exit the loop. So if we find it, we do it, and we exit the loop. Ideally, our bucket is of size 1, and so this is a fast operation. This for loop, if we have lots of collisions, lots of bad things, if our buckets get giant, we're in trouble. If our buckets get giant, we're in trouble. But this allows us to go in, find that index, remove it, and then exit the loop, and then we add our new entry in. We could add in some, again, there's some efficiency things, there's an optimization to do, say like, well, I don't want to actually remove it, maybe I use a linked list, instead of an array list. So that's why the hash function quality is important. Absolutely, Snabble, the hash function quality is so important. And so far, and lucky us, in modern development, we don't have to worry about it. In modern development, we really don't have to worry about it. If I wanted to cheat, and I'm going to, we don't have to worry about writing it. We don't have to worry about, Snabble, let me change, we don't have to worry about writing it is what I meant. Key.hash code. So for the most part, in most programming situations, in most modern languages, this is why things can be, there's a thing called get hash code that comes on most objects for free, in C# specifically. And then it's like, okay, I don't even have to worry about this thing. Right? So we could cheat this there. Yeah, Snabble, if it has multiple members, okay. So let's look at it. This is where the record struct in C# is magic. The record struct in C# is magic. All right, so if we have multiple members, what do they have? They have hash code dot combine key 57 banana. So yes. What if the record type is array? Then you're in trouble. Yeah, Snabble. This is what I'm saying. Like most of the time, choosing the correct key is super important. Excellent. Maybe just as sorry, a hash table is basically an array of linked lists, right? Where each element in the array is a bucket. Yeah. So our table here, each one of these are a bucket. Snabble. Oh, I've implemented hash tables many a time. We have suffered. Yeah. Sometimes you start. What I'm saying is, in most situations, you don't have to worry about this. What you really have to worry about is this get hash code. Get hash code. Turns out you have to write a good one. And this gets tricky the more complex your program gets. Writing a good hash code gets tricky. Can get tricky. If your data type's simple, then it might make a good key. If your data type's complex, if you have arrays, probably shouldn't be a key. It probably shouldn't be a key, Snabble. But you know that. You know that, Snabble. You know that. So we could just use this cheap trick here. Look. Hashers hate this one cheap trick. We were provided the DJB2 hash function use. Gotcha. Yeah. So it turns out there's like some complicated things you can do for string where it says, well, I'm going to take the sum of the characters and like do prime stuff and multi stuff. By the way, Snabble provides net.NET provides a fairly used interface called iStructural Equatable that can help implement hash codes and equals. Yeah, so when we were doing the Battleship game, we actually ended up using that for structural equality of like a game board, because it turned out it was a little bit tricky to get the game board to be like a hashing and stuff. Structural equality, cool. Yeah, structural equatable is important here. Okay. But we can cheat a little bit to use this, and then the reverse for get, the inverse of get is sort of, all right, we find the hash key, we look it up, All right. In this case, if the bucket is null, we throw new operation, or would it be like an index key not found exception? So if the bucket is empty, the key is not found. All right. And then otherwise, we loop through the bucket like this. All right. We loop through the bucket, same thing here. This one we could actually write as a for each loop. For each string, entry t entry in bucket. If entry dot key is equal to the key, entry here, I should rename these. Hang on, entry factor with a capital K and a capital V here. Capital K, capital V. All right, if it's there, we return entry.value. This should return a T. For each over list, perf bad. I think they fixed that actually in .NET 7. I think they've optimized it. Snabble, correct me if I'm wrong. It might be .NET 8. So Nick Chaps has had a really interesting video on it, saying that you used to have to worry about that, but it might have been a new feature in .NET 8 that where they optimized the compiler somehow. I don't know. Fix is a strong word. Optimization. I don't know the inner workings on that. But from what I understand, you don't have to worry about that too much. You don't have to worry about it too much. But I'm not sure. Olivia, welcome to the stream. How are you? Olivia, happy Thursday. Snabble is saying, and this could be correct, and you are correct, is saying that the for each is going to be slower than a traditional for loop. And it's true. It's a little bit true because it turns it into an I enumerator. From what I understand, there's some optimizations done there. Coleslaw. So is it Cole's Law or is it coleslaw? Was watching some of your stream in between rounds with JavaScript. You're an inspiration. Well, thank you. You're an inspiration. Julian, thank you for the link. Yes, Nick Chapsis. I love Nick Chapsis. Great stuff. Okay, so if we don't find an entry with our key matching, we're going to throw that there was no key found. Coleslaw. Gotcha. It reminds me of a joke. And now the joke's going to be ruined. Have you guys heard of Moore's Law? Moore's Law is the idea. Moore's Law. All right. Moore's Law is, this is an apostrophe here. Moore's Law basically says that the amount of transistors that you can put on a chip doubles every 18 months. 18 months, double memory. So a transistor is like essentially what we use to store memory. Every 18 months, memory doubles. So right now the cost of 16 gigabytes of RAM is gonna go down every 18 months, right? So we're reaching a point where it's hard to do this, hard to hit there. Creative Pepper, welcome to the stream, my friend. This stream reminds me of my time in college studying these things, nostalgic times. I loved it. All the transistors. Yeah, exactly. Okay. So Moore's Law is this rule. But have you heard of Cole's Law? Anyone heard of Cole's Law? It's delicious. It's sliced cabbage and mayo. It's delicious. It's a terrible joke. All right, folks. Yeah, so it's like you have to tell Moore's Law to set up that whole joke. It's dumb. Yeah, so the problem was coleslaw's already here. But yeah, if we talk about Moore's Law first, it's like the old magician trick of like, hey, look over here. It's hey, look over here. Is this your card? right? So you gotta trick them. You gotta psych them out. Psych them out. All right, but this is the general idea of our hash. Someone should put you in timeout. Now you're king, Scott. I'm so sorry. Maybe that's a good thing. Maybe that's a bad thing. I'm sorry, you're king. I hope you get a chance to have yourself some coleslaw soon. All right. So this is the basic understanding of how hash tables work. It's a little bit more nuanced and maybe not different, but nuanced. And this is as this thing fills up, we're gonna have to increase. We're gonna have to increase the size as our table gets more and more full. So there's this trade-off here, right? There's this trade-off. Typically, our table is gonna be really, really empty. Notice if I were to use this, if we look at our output here, I have 10,711 unique tokens. This isn't gonna be big enough. It's gonna be enough. But what if I wanted to be smaller? What if I could do 100,000. I'm really interested if I tried to use my hash table here instead of my dictionary. What would my speed be? It's going to be bad. It's not going to be good. 100,000 here, 1 million. How do you decide this number? This is like a really difficult thing. How do you decide this number? And so we kind of cheat the same way we did with dynamic arrays, where we say once we start having collisions, start having lots of collisions, we're going to increase the size. And oftentimes we'll be like, oh, my bucket, it's going to be up to you how you implement it. Best get the flamethrower. Yeah. What is the red squiggle on line 7? Did I fix it? I got 9,582 on my simplistic parsing of this book. Gotcha. What was your filter? My filter is really dumb, Smab. My filter is really dumb. And Smab, do you have I'd love to check out what you wrote. Basically, my filter is terrible. And so I'm saying, like, there's a bunch of extra stuff we could do to clean this up. My filter's dumb. If you have a dumb filter, you're gonna get dumb results. But it's good, I think, for demonstrative purposes, because we were demonstrating our purposes here. Yes, Smab, I appreciate it though. I really do. All right, remove the underscore and then use a regex with, remove the underscore. Remove the underscore and then use a regex with white space. That's your whole thing, is just a regex like that? Remove. And .NET 7 for each seems still slow. That's okay. Snab, I'm not too worried about it. My copy used underscore for emphasis. So Smab, I guess, sorry, I'm a simpleton. I'm not quite understanding your suggestion. I apologize. We'll have improvements for each .NET's, here, let's see, .NET 8 for each improvement. Microsoft Finance for each has been .NET 7. I think this is the video that it was. That said, I don't think you have to worry. Thank you for worrying for me. I appreciate it. Smab, yeah, please post it on GitHub. We'll check it out. Folks, thank you so much for joining. I know we didn't, I hope this was informational. I hope this was helpful. I hope you enjoyed this. I had a beautiful time here with all of you beautiful people. Smab, we're going to take a look at that once you share that leak. Folks, we're going to be wrapping up a little bit. I do have to start getting ready for work. I'm a teacher. Folks, for anyone who's new here, I am Captain Coder. Captain Coder is me, and me is a computer science educator. I teach computer science and programming at a school for ages 10 to 14. And every Tuesday, Data Structure Tuesday, Thursday, maybe not every Tuesday, most Tuesdays, where we're doing Data Structure Tuesdays, Data Structure and Algorithms Tuesdays. Thursdays is Game Dev Dave. Saturdays are Grab Bag. This Saturday, we're going to be doing, Mooniz and I are going to be doing a stream together. I'm looking forward to it, Mooniz. So I hope you guys will join our Discord. Come hang out with us, ask your questions, learn to code, learn to grow, help each other out. We're having a beautiful time here. Folks, if you guys don't know Mooniz, incredible developer. Give him some love. Smap, thank you for that. Folks, if you have any questions in the meantime, feel free to send them on over, and we'll take a little looky-loo at them. And then I've got to hop off here in a little bit, but thank you for joining me for this. Smap, let's check it out. Sorry, my brain, for whatever reason, wasn't able to grok what you were saying here. Replace, okay, replace this, and then later on you do a tokenize. So this is our content. Matches. For each match, you do that. Okay, so you don't, so a simple dictionary version. Gotcha. Very, very cool. Let's take a look at this, folks. SMAB, nice implementation here. It looks great. Okay, so this is interesting. Oh, partial class. I was like, that is weird. I hadn't seen that before. This is a cute little, SMAB. This is a cute little hack. I love this. I was like, how'd you do this in a top level? Oh, I like that. That's really clever. So we're using a regular expression. We're replacing all of the underscores. We're essentially removing all of the underscores, doing the two lower invariants like that. And then we have a dictionary that we're going to do our string ints. And so we're going to loop over this, and we're going to do matches on the contents dot cast match. What is so matches contents word pattern? Okay, so word pattern matches in word pattern. Okay, word regex up here. Sorry, my brain is having a little trouble here. Word regex. Is this a built-in thing that just says find words? I didn't know this existed. You didn't write word regex. Word regex apparently is a built-in word regex C#. Word regex, or did you? Is that something you built? Or is it from? I'm just assuming it's from this, since you're not importing. I'm assuming there's nothing else in here. Yeah, nothing else in here. Word regex. I've never seen word regex. It's a bit in the partial class. Oh, static partial class. I missed it. That's why I was confused. Gotcha. So your regular expression is saying W plus, which is saying to this saying find one or more words as defined. Oh no, this is white space. Is W regex? Hang on, regex. W is that built in for word? Hang on. W is in regex as a word? Yeah. Or is that white space? Why is my brain not working here? Word, yeah, match a word. I don't know why my brain is having trouble to understand that. Matches any word, character, alphanumeric, and underscore. Does it keep the hyphens for you, SMAP? Does it keep the hyphens for you? I'm just curious. Cool. All right, and then I'm gonna sneeze. Sorry, I'm back. Snabble, I'm not sure. We'll have to look into that at some point. I trusted Nick's Chapsis. You should trust and verify. Did not verify the claim. All right, folks. Smab, thank you so much for this. We're gonna get out of here, folks. We're gonna find someone to raid. Let me 1 second here. Bear with me. Here, I'm gonna get ready for work. We'll be back on Thursday. We will be back on Thursday for Game Dev Thursday. I hope you guys will come back. Redmer, thank you for being here. Thank you for lurking. Happy to have you here on this beautiful day. Let's find someone to raid. Julian, have a beautiful day, my friend. We're gonna raid Clayman Dev. Yeah, Clayman Dev. Let's do raid. Clayman Dev. Fantastic game developer. Fantastic game developer. Folks, once again, thank you guys for being here. Remember, keep coding, keep growing, be the best you can be, and you are welcome back anytime. I'll see you on Thursday.